design. One of them was that the arms were too heavy because when we started the design, we did with 9 millimeters MDF and the arms were too heavy. So we decided to leave the base on 9 millimeters, but the arms we changed them to 3 millimeters, and also we changed the third link. We have two pieces of 9 millimeters MDF, but we changed it to a single one of 3 millimeters. So in the third joint we have only one servo. But in the second joint we have two servos that are face one to another. And one servo has to rotate an angle and the other has to rotate to the contrary angle. We have also implemented caster wheels for the base because the base was put it on just in the servo, so the servo was the only support for the base, so the base kind of moved like this, and we had to give it support to the ends of the circular base. And we had some issues with the servo boards. We had some bad servo boards that didn't have a physical restriction. So when we send a value, they rotate continuously. We couldn't control it. So in conclusion, we have seen that the Jacobian will help us to control the velocity of the N effector in relation to the frame zero. That in our case it is located on the center of the base and the table that it will be put the robot. And the logical control interface is complicated, but it will help us to have a more visual control of the robot, to have the angles that we are sending, and also how it is behaving. There have been several issues that we didn't consider at the beginning, like didn't have support for all the base. So this is a big circuit. So we can solve it.
Here we have the reference. Then we go with the 6 degrees of freedom. The objectives is the same. The design build a simulation of the 6 degrees of freedom, and apply concept learning in previous courses, and also apply the knowledge we acquired in this course. And the Jacobian is the same, the definition of the Jacobian, we already seen that. And here's the model of our 6 degrees of freedom. We have 6 revolution joints, and here's the shape of the Jacobian. And the angular velocities, this is the final Jacobian for the angular velocities. And the linear velocity Jacobian of the 6 degrees of freedom, we obtain a huge matrix, so we split it into the first column, second column, third column. Each one is for the first joint, second joint, and third joint.
The linear velocities.
Yes, the linear velocities, and as you can see, we obtain such a huge result. And the similarities analysis for this, for the simulator. Here we based on some reference that mention the determinant of this configuration when we have a wrist. This is like the base or of the Jacobian. Here we can see that the J12 represents the linear velocity of the 3 third joints, and J22 represents the angular velocities of the rotation of the 3 rotational joints of the wrist. So here, and we obtain the determinant of the first of the last 3 joints of the wrist. We obtain that the determinant equals to 0. So this happens because the axis of the wrist intersects at a common point. And then the singularities of the wrist are determined by the determinant of the angular velocities of the last 3 joints. And then when we leave that, we obtain that for our architecture, it will depend only on the value of theta phi. And we obtain the determinant of the angular velocities equals to minus sign of theta phi. So the determinant will be 0 only when values of theta phi equals 0 and pi. So this singularity, what it indicates is that the axes C3 and C5 are collinear, and the only way to avoid it is determining physical restriction. So several authors that I read define that this was the only method to avoid this singularity. And for the other singularities, the analysis will be the same as the 3 degrees of freedom. For the 3 first joints. So the validation, we develop a code for obtaining the Jacobian for any type of 6 degrees of freedom, because we only change these parameters. So the calculations are the same, so we are able to use it for any type of architecture, but we use it for our architecture. So here are some images of the code. And conclusion about the 6 degrees of freedom, the importance of the Jacobian, because we can observe and we can use it further, for example, for the trajectories, and also we could use it for determining the velocities, the actual velocities, and the complexity of obtaining the Jacobian, because we struggle a little bit because the equations that we obtained, we had like several values, so it was a little bit harder. The reference for the 6 degrees of freedom.